Hello and welcome to the channel, The.multitutor. Today we will discuss our second case for differential equation, linear equations and further equations reducible to homogeneous function form or a separable equation. So, today's case is slightly different where we don't have a1 equals a1 over a2 not equal to b1 over b2. In this particular case, we need to make a substitution of smaller x is equal to capital X plus h, y is equal to capital Y plus k, and then try to solve it. Okay, this is a particular question which we will going to deal with in this particular video. First and foremost objective is to check a1 over a2 and b1 over b2 in order to ensure whether it's a case 1 or case 2 question. So there we have a1 upon a2, that is 1 upon 2, which is 1 by 2 only, and then b1 b2, that is 2 by 1, which is 2. So here a1 upon a2 is not equal to b1 upon b2. So we need to make a substitution of that is mentioned above. So we put x as x plus h and smaller y as capital Y plus k. Remember, because derivatives are exactly same, so we just need to write dy by dx in capital. Then we replace the values x plus h plus 2. Instead of y, we write it y plus k, and then we have minus 4. So minus 4 upon 2 x plus h plus y plus k minus 5. So just need to simplify it. X plus h plus 2y plus 2k minus 4, then 2x plus 2h plus y plus k minus 5. So we just separate x values and the constant values. Hope so. Till that point, you understand the concept that how we substitute the values. If you're new to the channel, kindly like, subscribe and share. Okay, in that particular case, or in that particular condition in this question, we need to make elimination of this and this. And this we can done through by considering as equal to 0. Mean we are considering that h plus 2k minus 4 equals 0 and 2h plus k minus 5 equals 0. This will help us to find out the values of k and h which we will use in the end when we simplify the answer. So how can we solve them? Just think. Yes, many of things that it can be solvable through a linear system of equation. They are right. We can either make a substitution or we can do an elimination method to do it. Just consider we have h plus 2k minus 4 equals to 0. So can I multiply this by 2 so that I make the coefficient of k same for the equation? So 4h plus 2k minus 10 equals 0. Now flip the signs. This will be crossed. So we will left with minus 3h minus 4 and positive 10 makes positive 6. So we have minus 3h equals minus 6. So h equals minus 6 by minus 3. So we will have 2. So h is 2. So we can simply find out the k value. That is, from this equation, 2 times 2, then we have plus k, and we have minus 5 equals to 0. So we have 4 plus k minus 5 equals 0. That's turn out to be k minus 1 equals 0, and we have k is equal to 1. Now the above equation will going to be simplified as dy by dx x plus 2y 2x plus y. Can you guess what is it becomes? Oh, if you guessed it, this now becomes a homogeneous function, then you are right. This has become a homogeneous function. So our next part is to just plug in the same substitution. Oh, okay. If you haven't gone through the topic of homogeneous function, how we solve the equations containing a homogeneous function, you have to check out the firstly that particular video, which is into the playlist. So now we need to put v is equal to y by x. Remember, should have to write capital Y and capital X, because now the variables are capital X and capital Y, not the smaller one. So we have x, v equals y. Now differentiate with respect to x. So x derivative, remember, hope so everybody knows, this is a product of two. So need to apply the product rule of the differentiation. So variable x derivative, v as it is, plus x as it is, the derivative of v, that is dv over dx, equals dy by dx. Now everybody knows what's the derivative of x. Yes, that is 1. So there is no need to write it, or you can write it in a further step as v plus x dv over dx equals dy by dx. Now the substitution becomes easier. So instead of dy over dx, we can write v plus v Now what about x? We write it x as it is, plus 2. Instead of y, can I say, check out this expression, that is xv. So if you check out, x is common, so 1 plus 2v upon x is common, 2 plus v. So can I cross this? Yes, I can. So x dv over dx equals 1 plus 2v upon 2 plus v minus v. Now takes the LCM, 2 plus v. So we have 1 plus 2v minus 2v minus v square. So we have 2 plus v. Then we have 1 minus v square. Why? Because these two are cancelled out. And there we have x dv over dx. Okay, now make a flip of a situation. Take this on the opposite side by flipping and x in dx on the opposite side. So 2 plus v upon 1 minus v square dv equals dx over x. Now, we have been able to make a separable equation. So, can I integrate it directly? No, firstly I have to make this into or separate it into a partial fraction. So, can I write 2 plus v upon 1 minus v square equals 2 plus v? Remember, this is based on a square minus b square, that is a plus b and a minus b. So, can I write v minus h and v minus h, sorry, v plus h, or whatever you want to do, that's good. You can even write negative first or positive after. There is no issue in it. Now, mix a let. So many lets are involved, so be careful. Equals a upon 1 plus v plus b 1 minus v. Now, multiply the whole equation by this. So, this will become 2 plus v equals a 1 minus v plus b 1 plus v. Next part is to put v is equal to 1. So, we have 2 plus 1 a 1 minus 1 plus b 1 plus 1, and a is eliminated because 1 minus 1 becomes 0, so eliminated, that becomes 2b. There we have 3, so 3 by 2 equals b. This is the value of b. Next, we put v equals minus 1. So we have 2 minus 1 a 1 minus minus 1 plus b 1 minus 1. So we have 1 equals, there we have 1 plus 1, because negative negative becomes positive and b is eliminated. So we have 1 equals 2a. So 1 upon 2 is equals to a. So there we have the answer of a as well. So the equation will become, which we need to differentiate, is 1 upon 2. Okay, everybody can say that we should have to write first 1 by 2. Okay, you can write it directly. 1 upon 2. Then we have 3 by 2 1 minus v. So next is the integration process, where we need to write it 1 upon 2 1 plus v plus 3 2 upon 1 plus v dv equals to integration of dx, sorry, should be capital. Hope so. Everybody knows or get the point up till now. Okay. What about the integration of this? We have 1 by 2. The derivative of v is 1 present above. So we can write 1 plus v plus 3 by 2 as it is. Okay. Can I write ln 1 minus v directly? No, I won't, because the derivative of 1 minus v is negative 1, which is not present there. There is a positive. So the best part is to just change the sign of this. If this is negative, I will make it a positive because it is positive there. So I just make a negative sign. The next point is ln x. And what about c? Okay, because this question already have so many substitution, so I will recommend to not go with c, rather make something different like ln c1. There is no harm in it because this is also a constant element, so it's quite regular that you can use it. Because if I don't use it, the question is still solvable, but that is a quite longer one because we first have to swap v with their original content, then the original capital X with the smaller x, so it takes a lot of time of yours. By this you can save your time. Okay, what about this? Can I write this as ln 1 plus v 1 by 2, then negative ln 1 minus v 3 by 2 equals ln x. Okay, can I write this? Because this is positive, so can I write c1x? Yes, I can. Now I can merge even them as well. So there we have 1 plus v 1 by 2, and then we have 1 minus v 3 by 2. Remember, these all are under 1 ln and ln c1x. Just check out. This helps us to eliminate ln because ln is contained on the both side. So I can write 1 plus v 1 by 2, 1 minus v 3 by 2, then c1x. So have we done it? No, I won't, because there are so many processes or simplifications left in it. We have to solve as much as simplify as much as I can, because this will make the ultimate answer most simplified before substituting the original values. So can I make a squaring of it? Squaring makes 1 plus v 1 minus v 3, and then we have c1 square, and then we have x square. Okay, now we substitute the original value of the v, that is 1 plus capital X, capital Y over capital X, 1 minus capital Y over capital X, 3 equals c1 square x square. So can I make the LCM of above? X plus y. X minus y whole cube c1 square x square. So x plus y over x minus y cube. Firstly, we need to write the x there. X plus y upon x minus y cube by x cube. So c1 square x square. There are many students will understand that x will be going to crossed, but for the simplicity of for everyone, I'm just making a division of it so that everybody gets the point that how we do it. Divided by x minus y cube by x cube equals c1 square x square. So x plus y upon x. Can I convert it to multiplication? Okay, I'm using a dot there so that it won't be confused with the multiplication. Now, can I cross this? Make it 2. So x plus y x square over x minus y cube equals c1 square over c1 square x square. So everybody knows that we can cross directly x square. Otherwise, you can bring x square on the opposite side in the denominator and they will be crossed. So up till then, we left with x plus y equals to c1 square. So do you think have we done it? No, still not, because we are solving for the smaller x and smaller y. We need to substitute them. So for x, we write it smaller x plus h. But remember, we don't write h because we need to write the value of h now. The value of h is, where is the value of h? The value of h is 2. So we will come on to there. Okay, firstly we will do the smaller x is equal to capital X plus h. So this turns out to be x minus h when we need to substitute it. So x minus 2 will be substituted there. Similarly, for y, we have smaller y equals capital Y plus k. So y minus k is equal to y. So y value is already, so I think the y is already a negative 1. Oh no, it's a positive 1. So we will left with minus 1 equals y. Now we need to substitute it into the original equation. So we have x minus 2, then we have y minus 1, then we have upon x minus 2, then minus y minus 1, so it is x plus y minus 3 upon x minus 2 minus y, then plus 1, then 3 c1 square. So x plus y minus 3 x minus y minus 1 3 c1 square. There we just make a slight flip of this equation, that we will replace this by a standard c. So we have x plus y minus 3 x minus y minus 1 3 equals c. So here c equals c1 square. Hope so everybody gets the point. Again, remember the simplify or simplification of the equation are different for different. I can make a flip of it, flip this with negative sign, and then write another answer, because if you find out the answer like this, oh, just check out. There is another way of writing an answer of this. I'm taking this on this there. We have x plus y minus 3. I'm writing this so in order to ensure you that if you found out this answer, you may perceive that we have done it wrongly, but we won't. Okay. If somebody flip it, can I flip it the answer? Minus 1, 3 upon x plus y minus 3 equals to c1 of negative 2, because I flipped the powers of everyone. So again, here I just need to write the answer as x plus y minus 1, 3, x plus y minus 3 equals c. C is equal to c1 negative 2. This is also a correct answer. Remember, whatever answer you write, it will be considered as a correct answer. Hope you understand the concept. And the next video, we'll meet you again. Up till then, goodbye.